this assessment gives us values for delta H and delta S. Before we talk about what the problem's asking, let's remind ourselves what these values mean. The delta H value that was given was plus 11.7 kilocalories per mole. I've written it as 11,700 calories per mole. This positive delta H is unfavorable. The reaction is disfavored based on delta H. The value that it gives for delta S, plus 33 calories per mole, that positive value for delta S suggests that the reaction is entropically favored. When we have an enthalpically disfavored process and an entropically favored process, there's going to be some temperature at which the reaction is neither favored nor disfavored. That's going to be the point at which delta G is equal to 0. And so if we want to calculate that temperature, we can rearrange our equation as follows, where we say that 0 equals delta H, 11,700, minus temperature, what we're solving for, times 33. And now by solving for T, we'll find that temperature. Well, we can rearrange this equation so that 33 times T is equal to 11,700. We can divide both sides by 33, and that's going to give us that the temperature at which the process is neither favored nor disfavored is 355 Kelvin.